All right, let's talk about ordering and comparing numbers, real numbers. So our goal is so I can order and compare rational and irrational numbers. So we're going to order them. We're going to put them in order from least to greatest. We're also going to just see what's bigger than what, what's smaller than what. And in order to do that, we got to know what in the world rational and irrational numbers are. So just to recall, here is a chart about real numbers, the rational and the irrational. So, rational numbers include pretty much all the numbers we use on a daily basis. That includes from natural numbers, the smallest subgroup that just has 1, 2, 3, just our counting numbers, to whole numbers, which is including 0, to integers, which is including negatives, and to rational, which is including decimals and fractions. Irrational, though, are those ones that never end. They're decimals that never end, and they have no pattern to them. So we're going to look at these and we're going to see how we can compare them to each other and how we can put them in order, maybe from least to greatest. So here's an example. So let's compare the following numbers using inequality symbols and convert them to decimals. Now, first of all, what are inequality symbols? Well, inequality symbols are those symbols that open up to the larger number. So that would be the less than symbol, this would be the greater than symbol, and then the equal symbol, if they are equal. So let's use those. Let's compare a couple numbers. So here's the first example: 3 5/8 and 3.662. So how do we compare those two? One's a fraction, one's a decimal. Well, that hint is so important. Convert things to decimals. If we convert them to decimals, they're comparable. We can see easily which one would be bigger. So recall 3 5/8. It's going to be 3 point something. We talked about this in another video, but 3 point whatever 5/8 is. So how do we figure out what 5/8 is? Well, we do 5 divided by 8. And we can write out the work here and, excuse me, do that, or we can just take our calculator and do 5 divided by 8, which is 6.625. So this would be 3.625, and this would be 3.662. So how do we open it up? Where does the symbol go to? It goes to the bigger one, which if we look at it, the first decimal point is the same. We have sixes in the tens place, and then we look at the hundreds place. The one on the right has a larger decimal, so we have opening up to 3.662, meaning that is the larger number. Let's do another example. Number 2. We got a square root here. The square root of 12 and 3 4/7. Again, go back up here. Convert them to decimals. Makes it a lot easier. So to figure out the square root of 2, we could estimate that, but I want to make it exact. So I'm going to put that in here. In my calculator, I'm going to put 12 and use the square root symbol. And I'll round it to a few decimals. We'll do, let's see here, 3.4641. How about? Then we got to check 3 4/7. We know this one's also going to be 3 point something. In order to figure out what 4/7 is as a decimal, we do 4 divided by 7. Seems weird because the 4 is smaller, but we just have to add decimal places there if we were doing it long division style. Or take your calculator and do 4 divided by 7. And you get 0.5714. We'll leave it at that. 3.5714. Now we can check their decimals, and they're both 3 point something. So the first decimal, we have 4 and 5. That means 3 4/7 is greater. So if we were to rewrite that, we'd say square root of 12 is less than 3 4/7. And back up at this top one, we'd write that 3 5/8 is less than 3.662. So that's comparing numbers. Let's do the same thing, just putting numbers in order from least to greatest. So more than more than two numbers. So put the following numbers in order from least to greatest. And convert them all to decimals. No way. But yes, that makes it easier. And actually, I think we just worked with these four numbers. So let's recall what those were. 3 and 5/8 was 3.625. 3.662. We got that. Square root of 12 was actually, we'll just do 3 decimal places this time. 3.464, and then we had 3.571. So now we have to put them in order from least to greatest, the smallest to the largest. So let's see here. Smallest first decimal is actually 3 point, this is the smallest, so 3.464. Next smallest would be the one with the 5. 3 point, actually I'm not going to use the decimals. I'm going to put them back into their original form. We use the decimals so we can compare them. I put square root of 12, that's the smallest. 3 and 4/7 is the next smallest. And we said, because the second decimal is smaller on this one, this would be the next smallest. So this would be 3 and 5/8. And then 3.662. There's your order from least to greatest. So I'd suggest trying this next one on your own. Put these in order from least to greatest. So what did you do first? Hopefully you changed them into decimals. So 4 and 2/8 would be 4.25, or add a 0 there. I forgot to do that. Add a 0 so we can compare them so they have the same decimal places. 4.250, or 250 thousandths. Then we have 4.667, that's already decimal. Square root of 23, if you use your calculator, is 4.796. And then 4.62, add a 0 to the end, so it's 3 decimal places, would be 4.620. You can compare those, and you find that the far left one is the smallest. Far right one is the second smallest. Then we have 4.667 and the square root of 23. And what I did was made the mistake here again of writing the last two not in their original form. So it went 4.667. Now I have the wrong color. There we go. 4.667. And finally, the square root of 23. So that's the order from smallest to largest. And that's really how you do it. When you're comparing or ordering numbers, you want to change them to decimals, and that makes things a lot more easy to compare. So there's our goal again. You can compare and order and compare rational and irrational numbers.